Hi, good morning, all. Welcome back to our channel. Today, we are going to solve this problem number 40. Find the value of load resistance such a way that maximum power will transfer from source to load and calculate its maximum power. Okay. So, this is very simple problem. Let us see here. So first we have to remove the load resistor. So in calculating this, first we need to find out VOC. How to find VOC is remove the load resistor and obtain the voltage across the open circuited load terminal. Okay. So here we have the source and here we have then current source parallel to an resistor and a 2 ohm resistor and a 3 ohm resistor and 2 ohm resistor, and here we have the resistor. So now we remove the load resistor. As soon as you remove the load resistor, this is open circuited. The voltage at this point is VOC and 0. So now when it is open, the current in this branch is 0 and resistance is 5. So therefore, when you find the voltage, V is equal to I into R, this is equal to 0 volts. Now this branch will act like an short circuit and automatically the voltage is, so the voltage at this point will be shifted to here and this will act like an VOC. Okay, so now let's try to use our methods to find out this VOC value. So this is VOC and this is an new node Vx. Okay, so now the procedure of solving this one is, this is a 15 volts battery. So now let us try to calculate. Okay, so let's try to apply nodal analysis is nothing but Kirchhoff's current law at node Vx. Then we can find out Vx and we'll find out the, so see here the procedure of applying the nodal analysis. So let us assume the current in this branch is some I1. So the current in this branch has some I2. The current in this branch has some I3. So you can see here only 1 amp source is entering. So total entering current is 5. The leaving currents are I1 and next current is I2 and the next current is I3. Okay, so when you solve it, so 5 is equal to, how to write down I1? Vx minus, okay, Vx minus the voltage is 15 divided by R value is how much? 1. So how to write down the current I2? So Vx, so this current I2, how to write down the I2? Vx minus 0 divided by 10. How to write down I3 current? Vx minus Voc. Vx minus Voc divided by 2. Okay, so solve it, you'll get one equation and we require the voltage at this point. Okay, so in order to find this voltage, let us try to apply nodal analysis, which is nothing but KCL at node VOC. So here you can see here I3 is completed. Let's try to mark this current as some I4, mark this current as some I5. Okay, so there is no entering currents, 0. The leaving currents are I4 is one current, another leaving current is I5. So 0 is equal to I4. How to write down the I4? Flowing from VOC to Vx. So VOC minus Vx divided by 2 plus I5. How to write down I5? I5 is VOC minus 0 by 3. So when you segregate these terms, you are going to get VOC by 2 minus Vx by 2 plus VOC by 3. Okay, so you can write down it as Vx by 2 plus, when you take VOC as common, which is 1 by 2 plus 1 by 3, this will be acting like an equation number 2. So from here also we can write down, so 5 is equal to Vx minus 15 plus Vx by 10 plus Vx by 2 minus Voc by 2. So from here, when you send this, no, this is 5 plus 15, which is nothing but 20, is equal to, take Vx as a common term. When you take Vx as a common term, 1 plus 1 by 10 plus 1 by 2, and next minus Voc by 2. Okay, so just use your calculator and find the values. Then we will get the values of Vx is equal to 15.38 volts and Voc is equal to 9.23 volts. Okay, so this would be the values what we are supposed to get, and we calculated the first part, which is nothing but Voc. So coming to the second part, how we are going to solve. Okay, so just I'm copying the circuit. Now same process, we need to find out RThevenin. So how to find out RThevenin is very simple. So whatever the sources are there, just remove those two sources. Okay, so this is an voltage source. This voltage source has to be deactivated and make it as an short circuit. And this is an current source of magnitude 5 amps, and this source has to be deactivated. Deactivating this source is indirectly making the current is equal to 0. So when you perform it, you can see here I am redrawing the network for more clarity. So here we are going to make it short, and here you are going to have a 1 ohm resistor, and this source is open circuited, and here we have a 10 ohm resistor followed with a 2 ohm resistor followed with a 3 ohm resistor, and ultimately we have 5, 3, 2, and this is what we have, and we need to find out RThevenin from open circuited load terminals. Okay, so here you can see here, this is 1 and 10. So now the current will flow and current will divide. If you have any doubt, mark this as node 1, 0, and mark this as sub node 2. Okay, so between 1 and 0, 1 is connected and 10 is connected, and these two branches are connected in parallel. Okay, so therefore between 1 and 0, I'm going to get, so 1 and 10 are connected in parallel. 1 into 10 divided by 1 plus 10. Okay, so then you are going to get this value as 0.9. Okay, and from 1 it is continue with 2, and the remaining network is followed. Okay, so this is 3 and this is 5. Okay, and here we are going to get R Thevenin. This is of 5 ohms, this is of 3 ohm, and again you can see here the current which flows, the same current also will flow here. Then I can say these two branches are again connected in series connection. Okay, so the resultant you are going to get a one branch here and another branch here followed with this branch. So this is 3, 5, this is 2 plus 9, which is nothing but 2.9. Okay. Once again you can see here the current enters here and current is divided between 2 and 0. So whenever current is divided, I can say these two are connected in parallel. Then you are going to get a one branch like this and a resistor like this. Okay, so this is of 5 ohm. This is product 3 into 3 divided by, so 3 into 3 product by sum 3 plus 3. Okay, when you make this is approximately 1.5 ohm, and again you see here the current which flows in 5 ohm, the same current also will flow. Then I can say these two branches are once again connected in series connection. So whenever they are connected in series, it will be reduced into one single resistor, that is 6.5 ohms. So this will be the value of our RThevenin. So RThevenin value is 6.5. So substitute all these values. So R Thevenin is 6.5, and already we find the value of VOC is 9.23. So 9.23 whole square. So just use your calculator, then you'll be getting the power as 3.27 watts is the maximum power transferred from source to load. So source is 15 volts and load is RL. This is the amount, and he has asked what is the value of RL. RL is equal to R Thevenin, that is equal to 6.4 ohms. When load resistance is equal to source resistance, whenever the load resistance is 6.5, then the maximum power transfer will occur. So hope you are able to understand. So just done a simple logic, just removed it automatically. This will act as a short circuited, and this node will come to here, and this will act as an VOC. So this is one new node, this is another new node. So to find this unknown nodes, I applied nodal analysis, then I had find the value of Vx as well as VOC. So one part of the solution VOC is completed. The next part, to find out RThevenin, voltage sources I have been short circuited, current source I had made open circuited, and I used network reduction technique. So these two are in parallel, I got one resistor, and this is two, and again these two are in series, I got one value. Again the resultant two are in parallel, and again the resultant are in series. Okay, so this you can solve more problems only when you solve number of problems or exercise number of problems. Hope if my explanation is good, if you feel comfortable. So if you have any doubt, just you mark the notes, then all the confusion will go off. So just you will be marking the resistors connected between the nodes. Hope you had understood clearly. Just study, go through the problem, go to the video completely. If you're unable to understand, watch the video second time and write down the given question and try to solve of your own. If you get the same answer, the confidence no one can give you. Okay, that's how to solve the problem. If you feel my content is useful, please like the video, and those who are studying the same subjects, your friends, share to your friends. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KB Tulasi Ram, and kindly support this type of free channels for the benefit of students as well as for the faculty. So thank you for watching the video. So hope we'll meet in the next video. Thank you for your time. Thank you for listening.